What does zero mean?
It's just a number that means nothing.
What does zero mean?
It's just a symbol that means nothing. Negative is a number that is less than zero. Negative is a number that is less than zero.
What does zero mean?
It's just a number that means nothing.
What does zero mean?
It's just a number that means nothing. Negative is a number that is less than zero. Negative is a number that is less than zero.
What does zero mean?
It's nothing.
What does zero mean?
I said it's nothing.
I said, what's negative mean?
It's less than zero.
What's negative mean?
Less than zero.
What does zero mean? Okay, what does zero mean?
I said it already.
What's negative mean?
I already told you.
What's negative mean? What does zero mean?
Why don't you understand?
What does zero mean? What's negative mean? What?
The negative is less than zero.
Okay.
Zero means nothing. Why don't you understand?
Okay, I get it now. I get it now.
I already told you.
Okay.
It's about
okay,
time.
I get it now. I get
Why
it.
don't you understand? Finally.
Negative is a number that is less than zero. Negative is a number that is less than zero.
How many squares make up the area? How many squares make up the area? How many squares make up the area? How many squares make up the area?
Area is the space within a shape. Just look and you will see. The space inside the perimeter. Hey, do you see? Every time I'm telling you math communicates, then who disagrees? I think you understand. You should agree with me. Every shape, every place you know has area. Like a field, a wall, even a football pitch. Now listen carefully, let me teach you how to measure it. Look, we can use even a meter stick. To measure the size, then to find the area, we must multiply. Square meter is a measurement unit for the area of the shape. We can also use square centimeters or square kilometers too. Listen carefully, my friend, what I'm telling you. There are so many shapes I can't mention them all. Triangles, circles, rectangles and squares on this wall. They all have perimeter and area too. And now I'm going to explain very briefly to you. Let me start with the square. It's the same on all sides. The same height, the same width, so you simply multiply.
How many squares make up the area? How many squares make up the area? How many squares make up the area? How many squares make up the area?
Now let's take a look at other shapes too. Like this rectangle right in front of you. Its area is also made up of squares. So to find it, we just count the squares in there. Counting all the squares, you will be sure to get it right, but let's save some time by starting with the height. Count.
1, 2, 3, 4.
You see, now you got 4, but you're not finished yet. There's still some more. Think about the other side of it. This long side here is called the width. Let's do it the same. Count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Now we know their height and width. Now let's multiply 4 by 10.
Square meter 40. How many squares make up the area? 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 Measurements. 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 Measurements.
Measurements.
Measurements.
Measurements of length.
Measurements.
Measurement of width.
Measurements.
And measurement of height.
Measurements.
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 Measurements of length.
Measurements.
Measurement of width.
Measurements.
And measurement of height.
Measurements.
There are a lot of measurements I'm talking about here. There are millimeters, centimeters, even meters. There are still some more you will learn later on. Measurements are used to compare and differentiate. Just use them for everything that you'll need. Don't be surprised, they will all work indeed. Rats and elephant tails have been used. It doesn't stop there, even pea pods do. Why are you laughing? Please don't laugh. When there's a will, there's a way, I say. Measurements.
Measurements.
Measurements of length.
Measurements.
Measurement of width.
Measurements.
And measurement of height.
Measurements.
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 Measurements of length.
Measurements.
Measurement of width.
Measurements.
And measurement of height.
Measurements.
There are a lot of measurements I'm talking about here. I repeat again, there are different types of measurements I'm talking about here. Ruler is used to measure length. I think everybody knows about this. Even your feet, step by step. I repeat to say, step by step. In the village, they measure farms of 1 acre by 70 feet wide and 70 feet long. They distribute farms, even selling them too. There's no argument when measurements are used. Measurements.
Measurements.
Measurements of length.
Measurements.
Measurement of width.
Measurements.
And measurement of height.
Measurements.
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 Measurements of length.
Measurements.
Measurement of width.
Measurements.
And measurement of height.
Measurements. 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 Measurements.
Weight and volume are two different measures. Weight and volume are two different measures. Weight is measured by kilograms. Weight is measured by kilograms. Measure volume by using liters. Measure volume by using liters. Weight and volume are two different measures. Weight and volume are two different measures. Measure volume by using liters. Mass is measured by kilogram. Mass is measured by kilogram. Measure volume by using liters. Hey, my friends, you guys are continuously learning. You've made me happy today. Aren't you having a good time? You see, kids, mathematics can be fun. Addition with caring now. Follow the order. Of place, values, ones and tens, hundred and thousands. Addition with caring now. Follow the order. Of place, values, ones and tens, hundred and thousands.
Now listen carefully. There's no rush. Just understand the grouping method used. When additions need caring, please listen carefully. Now open your eyes, please. Write 29. Write another 9. Under the 29, you see 2 place values, 10s and 1s. You see the number 2, this is place value 10. So we have 2 in 10s, that's altogether 20. The number 9 is in place value 1s. Don't be surprised, means there are 9 1s. Now let's add using this example. Start with 1s. 9 plus 9, how much do you get? This is so much fun. You know what? You get 18. Now write the 8 in the 1s column and then carry the 10 to the 10s column. Now the 10s have increased, now we have 3 10s. Do you understand? It's not that hard. Sing.
Addition with caring now. Follow the order. Of place, values, ones and tens, hundred and thousands. Addition with caring now. Follow the order. Of place, values, ones and tens, hundred and thousands. Addition with caring now. Follow the order. Of place, values, ones and tens, hundred and thousands. Addition with caring now. Follow the order. Of place, values, ones and tens, hundred and thousands. Addition with caring now. Follow the order. Of place, values, ones and tens, hundred and thousands.
Follow the order.
2, 4, 6, 8. Sometimes the path is not so straight. 10, 12, 14. Sometimes you just want to give in. 16, 18, 20. But if you try hard, the options are plenty. 22, 24, 26. Don't give up, no, don't give in. Skip counting, skip counting. It's just a clever way to count when you got a big amount. Ooh, skip counting, skip counting, skip counting. It's just a clever way to count when you got a big amount. Ooh, skip counting. 0, 3, 6, 9. Sometimes success will take you time. 12, You've gotta work hard to reach your dreams. 4, 8, 12, 16. You've just got to keep on believing. 20, 24, 28. Try your best each and every day. Skip counting. It's just a clever way to count when you've got a big amount. Ooh, skip counting. It's just a clever way to count when you've got a big amount. Ooh, skip counting. Ooh, skip counting. Ooh, skip counting.
You know, Uncle D,
Tell me.
subtracting by borrowing is easy.
Sing for them.
When you subtract big numbers, you can borrow.
Tell me.
Place values, ones and tens, hundred and thousands. When you subtract big numbers, you can borrow. Place values, ones and tens, hundred and thousands.
Listen. I'm telling you, it's important to know when subtraction is borrowing. It's easy enough to know. Let me give you the example. Remember this. 36 subtract 9. We want the answer. Let's place them in their correct columns. The 6 belongs to the place value of ones. The 3 belongs to the place value of tens. How much do we subtract?
We subtract 9.
How much do we subtract?
We subtract 9.
Exactly. Let's follow this through. Can we subtract 9 from a 6?
No, we can't.
Come again?
No, we can't.
Come again?
No, we can't.
So what should we do now? What should we do now? Let's remember the place value of 10. I can take 110 from there and bring it here to the side of ones with the 6 ones. Now we have 16 ones. So 16 subtract 9.
Now we can do.
Now we have 7 ones. And we took 1 from the tens. So now, how many tens are left?
2 tens are left.
How many tens are
2
left?
tens are left.
We have 2 tens left. It's simple as that. You just follow the rules. 36 subtract 9. You know the answer. The answer is 27. We follow the place values and we got our answer.
When you subtract big numbers, you can borrow. Place values, ones and tens, hundred and thousands. When you subtract big numbers, you can borrow. Place values, ones and tens, hundred and thousands. When you subtract big numbers, you can borrow. Place values, ones and tens, hundred and thousands. When you subtract big numbers, you can borrow. Place values, ones and tens, hundred and thousands. I want to know the perimeter for rectangle. I want to know the perimeter for triangle. Peri, meter. Peri, meter. Peri, meter. Peri, meter. Peri, meter.
Perimeter is a total distance around the shell. Adding all the...
I want to know the perimeter for a square. I want to know the perimeter for a rectangle. I want to know the perimeter for a triangle. Peri, meter. Peri, meter. Peri, meter. Peri, meter. Peri, meter.
Perimeter is a total distance around the shell, adding all the length of the size of the shell. The Greek word peri, it means around, and the Greek word meter means to measure. Yes, that's right. We measure around. Now follow this very carefully so you understand. You will know the total length going around the shell. There's a lot of shapes, some of which I will mention. There's a rectangle, triangle, and also the squares. Now look so that you can truly understand. Let me start with showing you the perimeter of this rectangle. The length and the width have already been placed. Now I start adding this up to know the perimeter. The length value is here, and I add it with the width value. I continue and I add the length here. And I continue to add with the final width here. How much is the perimeter? You know the answer already.
We got 30 meters.
Yes, that's
I
right.
want to know the perimeter for a square. I want to know the perimeter for a rectangle. I want to know the perimeter for a triangle. Peri, meter. Peri, meter. Peri, meter. Peri, meter. Peri, meter.
There's no big problem. I'm telling you, my friends. The rules are in place to make it easier. The perimeter of the rectangle is easy to calculate. What are you waiting for? Just multiply by 2. Do you know why? Let me tell you now. This shape has 4 sides. Each 2 sides are the same. With a rectangle, you can calculate the perimeter by adding the length times width and multiply by 2. There are lot of shapes. Lot of shapes. I cannot finish them all. For example, a square. All 4 sides are the same. So you can take the length of one side and multiply by 4. I'm not going to teach you. I know you understand.
Yes, we understand.
What is an area? Listen very carefully. It's a space within a surface of any shape, a rectangle or a square. You must understand. I'm telling you, my friends, so please stop cramming. Every shape has an area. As you can see now, I'm standing in an area. Even the spots on my skin, I'm saying this. Have area. It's easy to measure. We use the equal squares within the area of your wall. Have you succeeded to draw? Okay, start counting. I'm saying again now, start counting.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
You've got 20. Very good.
We are so happy to be swimming free. We are so happy to be swimming free. In the water we play, we dance and sing all day. In the water we play, we dance and sing all day. We divide ourselves up into equal groups. Each one is a half. We divide ourselves up into equal groups. Each one is a half. Each one is a half. 1, 2, 3, 4, 5, 6, 7, 8. We divide ourselves up into equal groups. Each one is a half. We divide ourselves up into equal groups. Each one is a half. Each one is a half. 1, 2, 3, 4. 1, 2, 3, 4. Take 1/2 of 8, and what you get is 4. Take 1/2 of 8, and what you get is 4. 4 out of 8 is the same thing as 1/2. 4 out of 8 is the same thing as 1/2. We are so happy to be swimming free. We are so happy to be swimming free. In the water we play, we dance and sing all day. In the water we play, we dance and sing all day. In the water we play, we dance and sing all day. We divide ourselves up in 4 equal groups. Each one is a quarter. 1, 2, 3, 4, 5, 6, 7, 8. 2, 2, 2, 2. We divide ourselves up in 4 equal groups. Each one is a quarter. We divide ourselves up in 4 equal groups. Each one is a quarter. 2 out of 8 is the same thing as 1 quarter. 2 out of 8 is the same thing as 1 quarter. We divide ourselves up in 3 equal groups. Each one is a third. We divide ourselves up in 3 equal groups. Each one is a third. Each one is a third. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 3, 3. We divide ourselves up in 3 equal groups. Each one is a third. We divide ourselves up in 3 equal groups. Each one is a third. Each one is a third. 3 out of 9 is the same thing as 1/3. 3 out of 9 is the same thing as 1/3. We are so happy to be swimming free. We are so happy to be swimming free. In the water we play, we dance and sing all day. In the water we play, we dance and sing all day. We divide ourselves up into equal groups. Each one is a half. We divide ourselves up into equal groups. Each one is a half. Each one is a half. 1, 2, 3, 4, 5, 6, 7, 8. We divide ourselves up into equal groups. Each one is a half. We divide ourselves up into equal groups. Each one is a half. Each one is a half. 1, 2, 3, 4. 1, 2, 3, 4. Take 1/2 of 8, and what you get is 4. Take 1/2 of 8, and what you get is 4. 4 out of 8 is the same thing as 1/2. 4 out of 8 is the same thing as 1/2. We are so happy to be swimming free. We are so happy to be swimming free. In the water we play, we dance and sing all day. In the water we play, we dance and sing all day. We are so happy to be swimming free. We are so happy to be swimming free. In the water we play, we dance and sing all day. In the water we play, we dance and sing all day. We are so happy to be swimming free. We are so happy to be swimming free. In the water we play, we dance and sing all day. In the water we play, we dance and sing all day. Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator is bigger. Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator is bigger. Time to see what have we got, an improper fraction is big on top. Time to see what have we got, an improper fraction is big on top. The numerator is bigger, denominator smaller. The numerator is bigger, denominator smaller. It's improper. Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator is bigger. Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator is bigger.
Come listen to me. Fractions are just a part of a whole. Junior knows fractions. Come on, let's go. Look at these mangoes in the lines. Count them up. 1 through 9. 3 of these 9 mangoes of mine is 3 over 9, all 3 9ths. Math is the language, it's not so hard. When we say a fraction, all we mean is a part.
1/2 the same thing as 2 parts out of 4. 1/2 the same thing as 3 parts out of 6. 1/2 the same thing as 4 parts out of 8. All these are fractions, yes, they're just fractions of a whole. 1/3 the same things as 1 part out of 3. 1/3 the same thing as 3 parts out of 9. 1/4 the same things as 1 part out of 4. 1/4 the same things as 2 parts out of 8. It's just math. Fractions are fun, ha ha ha. Fractions are cool, ha ha ha. Fractions are great, ha ha ha. Back to improper fractions. The numerator is bigger, denominator smaller. The numerator is bigger, denominator smaller. Big on top.
If you look at half, that is 1 out of 2. It's equivalent to 2 out of 4. And the equivalent in Kiswahili is wafikiana. If you say 1/2, that's like saying a group of 2 things, but only taking one of them. Take one and put it over here. Take one other and put it over there. Take the other and put it over there. So each of them is 1/2 of the group. Now 2/4, that's like having a group of 4 things and dividing it in half. So you have got 2 over here, 2 over there. Now you see it? In the group of 2, we are also dividing it in half. So we can say that 1/2 is equivalent to 2/4 because 1 is half of 2 and 2 is half of 4. Wow! You kids are gonna know your fractions. They're gonna be easy for you from now on.
Don't you forget, or else you will regret. Don't you forget, or else you will regret. A fraction is proper, the numerator smaller. A fraction is proper, the numerator smaller. Denominator is bigger.